Hi everybody! In the previous video, we created a simple factorial application that contains basic objects. Of course, this application can be modified and expanded. In this video, we will look at a few additional cases so that you can learn more about other platform features. For example, we can change the theme of our application. On the training platform instance, there are some ready-made themes that you can use. Now we have a standard theme, but we can change it to any of the available ones. For example, the dev theme. After choosing a theme, we can go to the form runner and see how our application has changed. In this case, we already see the widgets have changed. We can see here that the buttons have changed and now they look more interesting. You can also load your own themes and change the appearance of the widgets as you want. The next case will be about transitions between process blocks. Now, the process is set up so that the second form leads only to the end of the process flow. But it would be better to have a button to get us back to the first form so that we can do calculations again. To do this, first of all, let's add an arrow transition that will lead from the second form to the first form. A block can have multiple outgoing transitions, but to simplify the process logic, we can use gateways. For example, we can use a database exclusive gateway, because we can either exit the application or return to the first form. There's also a parallel gateway, and it allows for following several branches at the same time. However, in this case, we will not use gateways. We will configure the process so that it works without them. But keep in mind that this is a very good practice. For now, we will leave the process diagram as is and go to the form. On the form, we need to add the second button. Change its system name and label. One more very important note. Buttons have a property called action names. When you click on a button, the value of this property will be sent to the attribute called result in the current context. Now we have to remember that our form is with a strict context, which means that it will not be able to directly reach the default process attribute called result. This means that on the form, we need to create a string attribute with the same name. We will call it result. This name will be the key to the process attribute that has a special function. Check the input attribute box because we will need to link it with the process attribute. And then in the action name property, without pressing F, just type back. This is the value that will be passed into our attribute. If a form contains several buttons, each button must have an action name value to differentiate between the results they produce. This will allow us to avoid errors in the future, because if we leave this property empty, its value will not override the value of the result attribute. So the value of this attribute will stay the same as it was before opening the form. And this can lead to errors in the workflow logic. Now we will save the form and go back to the process to link process attributes with the form attributes. In the property form instance initialization values, add a new link. On the left, select the form attribute, and on the right, the process attribute. And here they have the same names. Now click OK. After linking the attributes, we need to write conditions for transitions. Now all the transitions in the process are standard. This means that the process will always follow them, but we don't want that. Now we will change its type to condition flow. Now, an additional field will appear to specify the conditions for the transaction. Double-clicking on this field opens the UDML editor, and here we will check what values is stored in the process attribute result and compare it with the value that will come from the form. Here, it's important to make sure that the case and spelling is correct and exactly the same as the value that was indicated in the action name property of the button. A single equals sign is a comparison operator in UDML. Now click Save. Also, for convenience, you can give names to the transitions to make them easier to be identified. The second transition can also be set as a condition flow, but it's recommended that if a block has several outgoing transitions, one of them must be set as default. It looks like an arrow with a backslash on it. This means that the system will check all conditions of all transitions. And if no condition fits, then it will use the default condition. This is necessary in case it's a really complex application and it's difficult to trace its logic. With no default transition, if the system checks all conditions and doesn't find the right one, the process instance will simply end its execution on the current block. But if there is a default transition, it can lead to a block that will save this process instance when nothing else is applicable. Then we can figure out where the process was supposed to end up and why it didn't. This is a good practice. Now save the process diagram and let's test the configured functionality. Process versions are displayed on the Process Versions tab here. Note that the version of the running process instance is not at the top anymore, because the top one is now the version where we have configured those transitions. The running instance will continue running with this older version. Therefore, to test the new version of the process, we need to delete the running instance first. Then refresh our application in the form runner. Now let's test the transition. We can access the process instance and see which values are inside. Now the result is empty. When we click on the back button, we return to the first form and the attribute result receives the value back that came from the second form. If we click on the exit button, the process instance will finish executing and the result attribute will receive the value exit. This way we have configured transitions from one block to another. Let's have a look at the next case. Let's not enter a number, but instead press the calculate button right away. In this case, the system as usual transfers us to the second form, but doesn't calculate anything, because we didn't enter any number. Now let's try to prevent the system from leaving this form if nothing is entered in the input field. To do this, open the input form and select the widget used for entering a number and set the required property to true. In this case, a red triangle appears on the widget, which means that this field is a required field. To make the system check whether all required fields have values, we must set the button's property valid form to true. Now save the form. Since we had no changes in the process diagram, we can continue working in the same process instance. The only thing to do if we are on this form is to refresh the page in the form runner. This is necessary for the changes to be displayed. Now we can see the red triangle here too. Let's try to press the button without entering any value. Now we can see a message stating that we have a required field and we must fill it to continue. Enter a number, click the button, and now we can finally get to the second form. Let's look at another case. Let's enter a number, get to the second form, and return back. Now, on the first form, we see the number that was entered at the first pass. This is not a good thing. And we should empty all data we entered on forms before, so that the user could simply enter a new number without deleting the old number from the field. To do this, on the transition to the first form, we need to add an additional script that will empty process attributes, so when we switch to the first form, we see empty fields. Let's add a script block. Here is the UDMS editor, but we still only work with UDM objects. Here we can clean the input value. For this, use a built-in UDML function called UDML null. The function returns a typed empty value. We can use this function when we need to erase a number. We could leave it like this because the first form contains only one value from the process attribute. But of course, it's better to clear all attributes since we don't need these values anymore. Remember that the combination of colon and equal signs is used for assigning values to variables or attributes in the UDML. Save the script, then draw a transition from the second form to this script. And another transition from the script to the first form. And don't forget to give meaningful names to the blocks. Save the process diagram. And again, we need to delete the old process instance in order to see how the new version of the process works. Now let's enter a number, press calculate, and check what values attributes have. Currently we have two numbers in the attributes. Now press back. On the first form we see an empty field and can check that all attribute values are cleared. What we should understand here is that on the second form, the result attribute actually got the value back. Then, when the process went through the clearing script, this value got erased. So when we got to the first form, all process attributes were already empty. Let's talk about platform languages in more details. We already know about the UDML language. When creating the Factorial application, we only used UDML, since we had to work only with UDM objects. However, Platform also supports JavaScript. When we insert a script in a process, we work in UDMS editors that allow you to use both languages. In this case, we used a built-in UDML function, Factorial, to calculate the factorial of the input value. Now, we will write a piece of code with the same functionality but in JavaScript. But before that, a couple of words on the usage of JavaScript in Platform. The Platform server uses the 5th edition of JavaScript. So be careful. Declaring variables with the let operator and other functions that are available in edition 6 or higher will not work. Here, for example, a variable is declared using the var operator. This must be taken into account. JavaScript is a case-sensitive and dynamically typed language, which means it doesn't require you to specify the data type of a variable right when it's declared. For example, you can declare a variable called test and not specify its data type. Later, you can assign to it an integer, string, or object value, and the JavaScript will be okay with that. At the same time, UDML is not case sensitive, which means that you can write functions and call variables either in capital or small letters, and the system will understand it. Also, UDML is a statically typed language, so if we pass some attributes or assign the result of a calculation to some function, data types must match. This means that an integer can only be assigned to an integer, a string to a string, and so on. Now let's try to write some code. I already prepared a function. It's not very complicated, so let's quickly run through it. We declare a function in JavaScript. It will be called Factorial. it takes a number as input. If the input number is 0 or 1, it returns 1. Otherwise, it gets into a loop and multiplies this number by all subsequent numbers up to the specified input number. And then it returns the factorial. This function can be declared in a separate object and then just call it here. But we will write it in the script. Next, we need to bind process attributes, which are UDM objects, to this JavaScript function. To do this, there is a UDM operator that allows for accessing UDM objects in the context of JavaScript. Now let's assign the result of the function to the output value process attribute. But this time we are not going to call a UDML function. Instead, we will call the new JavaScript function. Here, it's important to use the following syntax: JS, data type, and then in the brackets, the name of the variable. The type is specified exactly as in the documentation. You can find all the information in the UDML and UDMS principles section and the UDMS subsection. And if you scroll down a little bit, you will see a segment devoted to data types that are used in platform. In this case, our function will return an integer value, so we will specify UDML int. Next, between the brackets, we need to call the JavaScript factorial function and pass it the UDM object input value as an argument. This is how you would use a JavaScript variable. Here, the value of the input value process attribute will be passed to the JavaScript function. The function will be executed and the result of this function will be assigned to the output value process attribute. We can also do it in a different way. For example, we can declare a JavaScript variable, let's call it inValue, and assign the value of the input value process attribute to it. Then we can just pass this variable to the JavaScript function. Pay attention to the syntax. It's important to remember that the assignment operator in UDML is the colon and equal sign, while in JavaScript it's just one equal sign. If we compare values, in JavaScript the comparison operator is two equal signs, while in UDML it's just a single equal sign. So there are some syntax differences that you should always keep in mind. Now we are ready to test the script we have written. Let's save changes in the script and in the process. Again, if you have a process instance running, you need to delete it because we have made some changes to the process diagram. In such a situation, it's advisable to work in two different browser tabs to monitor if everything is working as it should. Now we are on the first form. When we click the Calculate button, we will enter the process script. And in the form runner, we see that we have reached the second form, and the result has been calculated correctly. And in the application designer, we also see that we have gone through the script successfully. If we had any errors in the process, we would have been stuck on one of these blocks, and it would have been highlighted in red, and we would have found the corresponding error message on the Execution Errors tab. Let's have a look at another interesting improvement related to saving the information about running process instances. Now, we don't have any types in our application that would store the history of user actions, factorial calculations, and so on. We will fix it now. To do this, we need to add a type to the data package that was created in advance. Again, the name of the type is recommended to be written in the snake case notation. This type will be called data factorial. And here we will clearly see why the box Allow Manual Issuing of Physical Names was checked when we created this application. Here we ourselves assign physical names to the database tables, and the prefix that was defined while creating the application is automatically added to these names. Click Save. The new type appears in the application structure, and the type editor opens automatically. The first tab is called Attributes. This is the tab where you can add columns to our table. In Platform, they are called Attributes. And again, it's important to set the data type for each column and manually set its physical name. As we have two values, input value and output value, we will add them here and select the integer type for each of them. Let's save the attribute. In a similar way, we will now create the output value attribute. I also suggest that we add one more attribute to store the login of the user who started working with our application. We will call it user. A login is a string value, so we will leave the attribute type as string. Now we see that the system gave us a warning that user is a reserved word and we can't use it as an attribute name. Let's call it user login instead. Platform has a set of such reserved words, and you can learn more about them in the documentation. The attributes have been added to the type. And now we need to bind the main process to this type so that values can be stored here. Let's open the process. Here, I suggest adding a script block before the first form. In this block, we will create an object in the data factorial table and work with it in the process. And link the script block to the form block. Now specify the block name. Let's call it initialization. Here, we will first modify the set of process attributes, then adjust the forms, and then return to the script. I will not delete these attributes just to save time, but you can remove them if you want. So we will create an attribute called data object because it's going to be an object. This means that the data type of this attribute is not a simple type such as integer, string, data, or boolean, but it's a reference to an object. Therefore, select the type reference data type and then select the data factorial type from the drop-down list and click Save. Now that in the type column there is now a link to our newly created type. Now in both form blocks in the process there is a connection between form attributes and process attributes. So both application forms use the simple process attributes we created previously. We need to adjust this a little bit. I will do it in the following way. I will keep the input attribute of the form, but change the input value here. And select the input value field from the data object process attribute. Please note that the data types are the same. This connection is correct. Click OK. In the second form, I will show you how it can be done in a different way. Let's open the second form and delete the output attribute. And instead, we will create a new attribute that references an object. Let's call it data object. Select the type reference data type and select the data factorial type from the drop-down list. Please note that an error appeared on the Errors in Expressions tab on the form. This means that something is wrong. If you read the error message, the system is warning us that the form is calling the output attribute. But this attribute is not on the list of attributes as we have just deleted it. This means that there is a widget that still refers to this non-existing attribute. We will fix this error now. Double-click on the value property of the widget. Here, instead of the output attribute, we will specify the output value field of the data object form attribute. As an experiment, we will do something else. In the label property of the widget, we will refer to a UDM attribute. Through the F button, we will write the same text that we had before, but add the value of the number that was entered on the form. Since the input value is a number and there is some text on the left, we need to use the UDML function text to convert the number to text. This way, we can concatenate these different data types correctly. Save changes on the form. Now let's go back to the process. Since we have removed the output attribute on the form, we need to bind the new form attribute to the corresponding process attribute. Now that when I created the form attribute, I didn't check the input box. This is one of the most common mistakes made by new developers. If your attribute is not in the list, then you need to return to the form and modify the properties of this attribute. Now let's go back to the process and bind the form attribute to the process attribute. Now there's a good question. Which is better, to bind an object to an object or select individual object fields, like we did in the first form? In fact, it depends on the specific case and the application requirements. For example, in the input form, we need to display only one field of the object, and we know for sure that no other fields are needed. So we can pass only one field to the form. If we know that other object fields may be needed on the form, then it's better to pass the entire object. Now let's save the process diagram. And now we have one last step left. We need to adjust the scripts. We need to write a script in the first block and modify the existing script in the other script block. Since we are already working with the data object process attribute, here we also need to make changes. We are already familiar with this script, so I don't think it needs to be explained much further. And now the initialization block. Here we are working with UDM objects. First of all, we need to create a new object in the data factorial table. To do this, in the process attribute data object, we will assign the result of the method that creates the new table record. For that, expand the search methods group, find the needed type and select the method UDML new. You can read more about this method in the documentation. After executing the first script line, a new empty record with 3 empty fields, input, output, and user login, will be created in the table and will be assigned to the data object process attribute. Since we have an additional field, user login, we can fill it in here as well. We will assign its value using the UDML function current user. This function returns the login of the current user as a string. Therefore, all data types match, and the script is completed. Now save changes in the process. And now a very important remark. Before testing the new functionality, it's necessary to note that the changes we have made have affected the data model. In this case, it's necessary to relaunch the application in order to synchronize these changes with the database. Confirm the relaunch and refresh the page in the application designer. Now we can test the modified application. Since the changes have also affected the process diagram, don't forget to check if you have a running process instance. If so, it must be deleted. Now let's test the application. The application has been launched and we see the first form. This means that we have passed the first script successfully. If we look at the process instance, we will see that everything is in order and without errors. Let's check the Data tab. In the Data Object attribute, we have a new object where the input and output values are empty and the user's login is specified. Everything is okay, apart from being present on the Data tab of the process instance. This object can also be seen in the type itself, on the Data tab. Here is record number 1, and we see that the object has been created and the user data is specified. Let's enter a number and click Calculate. We see the result and everything is correct. And again, in the Application Designer, in the Data Factorial type, we can see what is stored in the input and output values. Now, please note that the process diagram is built in a way that if we repeat the workflow, we will be using the same object. If we go back and write another number, for example, 7, we will see the changes in the type object. Only if we start a new process and delete the existing one, a new object will be created in the type. Let's check if this is true. As you can see, another record has appeared in the type. This way, we have also learned how to create types and manage data in a process when working with type objects. While testing the current settings, you may have noticed that after moving from the second form to the first form, the values have not been erased. This is due to the fact that we didn't edit the data clearing script, and it is still working with simple process attributes. But the data object attribute is not called and not cleared. There are several ways to fix this. First, we can clear individual object fields. For that, we can again use the UDML null function. In this case, we will have an empty object field where we can store new values. In case we want to create a new object on each pass, we can clear the entire object using the same function UDML null. This way, we can modify our application and add new functionalities. Now we have finished examining additional cases in our Factorial application. In this video, we have learned how to change the theme of an application, configure transitions in processes, validate form widgets, create types, clear object data, and write scripts in UDML and UDMS.